to explain the nature of new computer and revised computer. So for example, if you use NVIDIA GPU, you have a lot of experience on that architecture. Basic part of GPU architecture is same, but enhanced, of course, for new generations. But our architecture is very first one, so we have to know about the processor itself to make it run efficiently. So it takes time. So the great thing is, even if we made only 40-some%, not so high efficiency, we got number one. That is actually most surprising thing. And this time we got almost 40 gigaflops per watt. That is, the number itself is very surprising, but the performance of a processor, theoretical performance of a processor, matches to that number. Not the first number, 21 gigaflops, is too low actually. We have DRAM and some layer of SRAM. Because we have a hierarchical chip, so there is some register around the matrix arithmetic unit. Then some of MAU shares some SRAM. So this is kind of tree structure. So on the root of the chip is called L2B, layer 2 block. Then we have 8 layer 1 block in a single layer 2 block, and 16 maybe, 16 matrix arithmetic unit in a layer 1 block. So this is kind of very complex structure, and total amount of SRAM is, that number is not yet disclosed. So we updated our equipment to keep the frequency higher to meet the level 3 requirement. At the same time, we can now know more time frame. So the total amount of energy should be measured by either way, because our system is small, so anyway we can measure whole system easily. But when the energy has consumed is different. So for example, maybe you remember power consumption graph that starts from higher consumption, then becomes much lower, and then the computation finishes.
Yeah.
This graph shows how much computation is running in parallel, and we found if something bad happens, power consumption fluctuates. So because some communication, for example, some communication does not go smoothly, then some part of our computer may halt, waiting to the data. Or maybe, I'm not sure what exactly happening, but something wrong. So the waveform can give you some hint what is happening, or if the computation is running smoothly. We have tried, and we have tried with AMD hardware, AMD CPU, and it worked.
Wonderful.
And we have never tried yet on ARM processor or RISC-V processor. Our initial strategy is to make our computer by ourselves. So because we are a deep learning company, so we do many business on deep learning, and we need plenty of computing resources. And our effort on MN3 is part of it. And we will extend our MN core-based computer to accelerate our own business. But as you know, that is not to rationalize the new ASIC cost, because the initial cost is very high. So we'd better to make much more chips to make it more competitive. So we are going to make a next generation of chip, and at that time we will make something. So actually the strategy is not yet decided, but so we came here. One reason we came here is to find the best strategy that fits to this field, because initially we are focusing on our internal usage. So we are open to listen to the people who want to use this kind of accelerator. we expect next generation of our processor MN Core 2 will come to running state at 2023. So we are now evaluating our new ASIC, and it will be available in next year, and we will build some infrastructure on 2023.
Wonderful.
So at that time, it will be a totally different system. For me, it's second SC conference, and as an exhibitor, it's first conference. So everything is very new for me. So we have some colleagues who have more experience in SC, but for me, it's very first experience. So everything has changing, and maybe we can do something to make it the world better, including deep learning, because our business is deep learning and computer. And if we can collaborate with people with HPC field, because we are a new player, we appreciate anyone who can work with us. What we expect is 2023, we will make some open platform. So I think we can report it the intermediate step toward the open platform, and we expect at that time we can find some business partner to explore some business field, including the markets in the United States or Europe or other portion of in the world.